Hey everyone, thanks for tuning in to the Medis Minute. On today's show, we're going to talk about Hydronics 101, the very basics. But first, the Medis Minute. Today's Medis Minute is on crankcase heater. A crankcase heater is a small electric resistance heater installed on a compressor to prevent refrigerant migration and oil dilution during off cycles. When the system is shut down, refrigerant naturally seeks colder areas, and the compressor's crankcase is often the coldest point. Liquid refrigerant can migrate there, condense, and mix with the compressor oil. On startup, that diluted oil foams and is carried out of the crankcase, leaving the compressor bearings and moving parts unprotected. This causes poor lubrication, excessive wear, and even mechanical failure. By keeping the compressor crankcase slightly warmer than the surrounding refrigerant circuit, the heater ensures refrigerant stays in the system piping instead of cooling the compressor. In short, the crankcase heater maintains oil integrity, prevents refrigerant migration, and extends compressor life. Thanks for listening to today's Medis Minute. Now let's start the show.
The Medis Tech Show. Welcome to the Medis Tech Show, a show for HVAC professionals by HVAC professionals.
I like how you guys bounce back and forth between heat pump talk and food talk.
The Medis Tech Show.
Mitsubishi.
All right, so we got the DSG conference next week.
Next week.
Yeah, I'm flying in Sunday.
Yeah.
And one thing I'm terrified of is right now is the amount of food that they bring out.
I know.
And did you go to the Kalahari for the Diamond Conference? All right, because the Kalahari is in Austin, Texas, Round Rock.
Okay.
Actually. And all I remember is Paul and I were set up with the podcast booth, whatever
Yeah.
you want to call it, table. And then food just kept coming out. And it was like, it seemed like every 2 hours something would be out there. It was like pretzels and Cinnabons and all this stuff. And it's like, was right in front of us. And Paul just kept coming back to the table with stuff. And it was cakes and everything. So I'm trying to stay away from that. Trying to go on some kind of a diet.
Yeah.
So I've been doing like the carnivore thing.
Okay. Yeah.
So
Yeah. How's that going?
yeah, all right. I enjoy eating the food.
Yeah.
Because it's all meat.
Yep.
I mean, it's fantastic. So staying away from all the carbs and just eating steaks and hamburg and eggs and
Yeah.
whatever comes from an animal.
Yeah.
So,
Yep. It's not a bad idea.
I feel better after doing it for about a week and a half now, 2 weeks. I do feel better. I don't feel as bloated. So, hopefully it's terrible because I love carbs. I love potatoes. I love all this stuff and I can't eat it anymore. So what the hell am I going to do next week when they got these full buffets of food? I'm just going to have to like pick and choose my proteins.
Yeah. And fill up on them too. Because that's the real thing is like if you feel stuffed from protein, the carbs don't matter as much.
Right.
Because I started doing, I think I told you, but I have Chat GPT doing my diet planning for me.
yeah.
So I had it I kind of made a weight loss goal. I told it my weight, my height, and my age, and it gave me, how many calories I should be eating. And so I just take a picture of my plate or I log if I have a snack or something, and it just keeps an eye on it. But, it's easy when you're home and you're doing all your meal prepping,
Right.
but it's when we travel. When you go to Kalahari or like even last year, the DSG conference, there was, what was it? Like soft baked pretzels.
Yeah.
And that was between breakfast and lunch. So you had your full breakfast, and then before lunch came out, they put out soft baked pretzels and the Cracker Jack and the little burger
it's
sliders.
like,
and,
oh my God. And I get so stressed out thinking about future things like the holidays. Look, I love Thanksgiving. I mean, I'm like, I think what I got to do is I got to get in the mindset of I'm going to eat really good up until Thanksgiving. And then I have that one day where I can have my stuffing and potatoes and all that.
Definitely.
And then just get back into it. And then Christmas comes around. And then you got this person's house, that person's house, ham, and God knows what else, and Christmas cookies, and it's so I get all stressed out, and it's like I want this stuff, and it's in front of me, so I gotta just it's self-control, you know, and then the other thing too is, you know, you like to have a little cocktail, little drink here and there, some wine or something, you know, whatever, nothing crazy, but even that is not part of the carnivore diet.
No, absolutely
it's all carbs.
Not. They don't have meat alcohol yet?
No,
not yet.
No,
I'm sure they will.
Not.
But
yeah, next week should be interesting. Trying to stay away from all that and have Paul picking on us and picking on me anyway. And when I'm eating salad or something, but even that, I can't eat salad because carnivore diet, salad's not part of it.
Yeah, I am kind of in the same boat. Started to try to dial in on the diet, and one of the things that I saw, which is pretty cool, and you might actually benefit because you're doing the carnivore thing, is I went to BJ's and I bought this sirloin that was about this long. It was like 4 pounds. And I just cut it into my own steaks, and then I threw them in the freezer. And so the last 3 nights I've had steak for dinner, prepared different ways. But, you know, it was $34 for, I forget what it was 4 or 5 pounds. I'm like 4 pounds maybe. So I came out with 8 steaks, 1-inch steaks. So not huge, but 1-inch steaks, pretty decently sized. And I came out with 8 of them for $30. So it's like you can't really beat that. You know, if you get them pre-cut, it's, you know, way more expensive. So I know next time I asked the butcher when I was there, I said, I was looking for a specific one called a chuck roll. So chuck roll is they call poor man's ribeye. So a chuck eye steak, it's similar to a ribeye. It's got the fat like a ribeye does, but it's usually less expensive. And so I asked him, do you have a chuck roll, which is just the long, you know, the bulk version of it? And he said, I'm doing those in like 5. It's like 5th on the list. And I was like, all right. So I told him, I was like, if I call ahead, can I have one ready when I come to pick it up? He's like, oh yeah, for sure. So I just got to call BJ's next time and say, hey, I'm coming to get my chuck roll.
I got to do that. Yeah, that makes sense. Definitely. Yeah.
Welcome everybody to the Metis Tech Show.
Yep.
It's just me and Steve here today.
No Paul.
Where's Paul?
Yeah, Paul's getting on a plane right now.
Oh yeah, that's true.
Yeah, he's on his way to the airport. He's in Atlanta. He's doing, you know, boss things. He's the boss, so he's doing boss things out there.
Yeah.
So he can't be on this one. So we thought, hey, let's take this time to talk about hydronics.
Yeah.
Like kind of a kickoff to all of our air-to-water products and, in the future, water-to-water products. And for those of you listening that are in the Northeast, in upper central United States, Northwest, we all know hydronics. This episode, you might want to tune out right now because this is basic hydronics, right? How do we move water from one point to another, and how do we heat it? And it's some of this when we go down to Georgia, to our headquarters, and you talk to some of the engineers down there, they're not familiar with hydronics.
Yeah.
You know, typical residential hydronics. And we're going to be doing a lot of training, internal training for everybody, sales and our tech support, and getting everybody that is not familiar with hydronics up to speed with hydronics.
Yeah. Yep. I think that's a great idea. I mean, little spoiler alert, but we are currently in the process of putting in the EcoDan air to water at the Boston Training Center. And so that's what kind of sparked this idea was, you know, we're sitting in supplyhouse.com and going, what hydronic components do we need? And you realize how quickly that list adds up when you start looking at all your valves and circulators and all that stuff. So this is kind of like what I thought would be just your introduction into the basic components of any hydronic heating system.
Yeah, and it reminds me a lot of back in the day of dressing, what we used to call dressing a boiler.
Yeah.
Whether you were removing an old boiler and just doing a swap out, there was always some components that you have to upgrade. Maybe you're removing some steel piping and going to copper and adapting that to the replacement boiler, or you're doing a brand new house.
No.
Those were my favorite.
Yeah.
Brand new house, brand new boiler, maybe a 5-zone system with zone valves, maybe 5-zone system with circulators, maybe a 10-zone system. But when you're done, and at least when I used to take pride in
Oh, yeah.
the piping and the soft soldering and make sure everything looked legit, nice straight piping, and take up a good section of the customer's basement with a wall with all of the hydronic piping. I loved doing that.
Oh, yeah.
Loved it. It was very satisfying looking back at that and saying, "Wow, look at this job I did." But this is all reminding me of those times, and I'm trying to remember how these components worked.
Yeah, your rules
back
of
in
thumb.
the day, and
Yeah.
Yeah.
Well, it's funny because, to me, like hydronic piping is where the trade meets art. Because if
Yeah.
you've ever gone to a house that has a beautiful setup, especially like location of isolation valves, having plenty of isolation valves, like when it's set up nice, I mean, it's not only does it look visually appealing, but it's obviously really easy to work on
Yeah.
as a technician. But I was the same way. I would my favorites for me were you'd go to a retro where it was an old boiler that was slapped together, and now
Right.
you have to go, okay, I'm going to cut out this section of piping, and how can I reroute everything to make it look nice and neat and something that you can be proud of. And I can't tell you how many pictures I have on my old phone from when I was in a van and would finish boilers, and I'd take
you
a
had a
picture of all
phone.
my work. Yeah.
I probably had a Polaroid camera if I was lucky back in when I was doing boilers. But things have changed. Boilers now, I get students that are coming to class and they're like, "Yeah, did you see this new boiler? It's got built-in Wi-Fi and Bluetooth." And I was
Yeah.
like, "What?"
Yeah.
Things have changed. Circulators now have inverters in them on boilers, and so we can dial in the GPM much better. It's just things have changed so much out in the field, but the basics haven't, right? We're basically heating water and moving it with a pump.
Yeah.
At the end of the day, that's what we're doing.
So that's what I wanted to start with is just basically what the hydronic loop looks like. And essentially you have your heat source, which could be literally anything. So it could be a oil burner, which is what I started with, which is just a pistol style burner. It atomized the fuel at a high PSI, high pressure, would turn it into a mist. It's like a spray bottle at constant speed. And then there was a little igniter, and the spark would go across it, would ignite, and it goes into typically a cast iron heat exchanger. And that cast iron just heats up and it stores heat really well. And
You want to talk about art? You mentioned art before.
Yeah.
That is an art in itself, being an oil burner technician. I'm telling you, because I've gone on calls before, and that was just not for me. Adjusting the airflow, the right size nozzle, cleaning the nozzle, making all of these things. It's very intricate. So when you see an oil burner technician, he's usually covered from head to toe in soot and oil. He doesn't smell he smells like a diesel truck, right? But that guy is an artist.
Yeah.
He's an artist to keep that oil burner to keep it burning correctly, so you don't soot up the system.
Yep.
You're not putting out soot, and it's efficiently heating that water. I just wanted to throw that in there.
Yeah. You didn't work on much oil, huh?
A little bit.
Yeah,
Yeah.
okay.
I got by. I've hit a reset button, a few times.
A couple
in my
times.
career.
That's funny. Because for me, I started in Vermont. That was the first job.
So you were
more than half of the homeowners were oil. So that's where I really learned about combustion in general. Gas was like a couple of years down the road. It was like 2 years before I worked on my first gas system on my own. And it's a lot different because they really don't produce soot unless something is horribly wrong. And it's a lot of switches. It's really a lot of low voltage control based. Whereas oil, I've always said an oil technician, he's a mechanic.
Yeah.
Because you walk up to a system, you hit that reset button, and you're listening. You're going, okay, oh yeah, I can hear the pump squealing. You got a bad pump. Oh no, your coupling is all shattered. I can hear it rattling around in the motor. Right, so there's a lot of noises that you're listening for. Sometimes you change out the nozzle because of the noise it makes in the chimney. Right, some people need a B nozzle, which is a hollow nozzle, and then that's what the boiler calls for. But for whatever reason, when it runs, it makes this whole rumbling through the house. You switch it to a W nozzle, and all of a sudden, it's nice and quiet. So it's all a lot of using your senses, whereas a technician on a gas side is usually using your instruments, tools, things like that.
A lot of maintenance with oil too.
Once a year.
You can get
at
away
least.
with neglecting your gas boiler for a few years, but you're not doing that with oil.
No.
And that's a whole nother side of the trade right there. Just the maintenance of an oil burner.
Yeah. Yep. So yeah, oil burner. It could be gas, which typically they have just like the row of burners, almost like you'd see on a grill, but it lays underneath the cast iron. The heat rises and heats the cast, which in turn heats the water. We actually worked on some pellet boilers. So a wood pellet boiler, really similar premise, except for typically when we would install them, it was all going to a very large buffer tank. So it was just like your typical pellet stove you'd have in your house, where there's a hot surface ignition that's initially sparking the dry wood pellets, and then there's an auger in there that's adding pellets as we go, and then there's a sweeper arm that keeps the soot from, or the fines from collecting. But all the water that gets heated from that heat actually just goes into a large buffer tank. So it's just maintaining a buffer tank temperature, and then all the hydronic piping to the zones in the space are all piped off of that buffer tank.
And usually you'd have like a fuel-fired boiler as a backup.
Yep.
I've worked on the same type of boiler, a wood-fired boiler, where they're throwing in like 5-6 foot logs.
Yep.
And they're they can heat that water for days.
Yeah.
But a lot of work.
and
I had a friend of mine that had
keep
one,
an eye
and
on.
all he did was spend time in his yard chopping wood, trying to find wood for the boiler, and it is a lot of work on the other end.
Yeah.
But it pays off.
It does
pay
Yeah,
off.
you can save some money that way. Yeah, we had some people that would run underground water piping into their boiler, and then essentially during the winter time, they'd switch a couple valves and go off of a plate heat exchanger. It's a really large plate heat exchanger that would take in the hot water coming off of the wood boiler to heat the boiler water.
Right.
And the reason for that most of the time is because the boiler water coming off your wood boiler is not as controlled.
Right.
Because it's just wood that's heating it up, so it's harder to dial in exactly, whereas your fuel side, it's got a high limit. As soon as we hit that temperature, it shuts off. So it was just a way to keep those two systems separate.
Right. Yeah.
So yeah, the heat source could be anything, but essentially it's heating water. So it's taking that heat source, it's transferring it to the water by some sort of means, and then there's a pump that's moving that water through the system to the loads, which would be your baseboards. You could have an air handler that has a hydronic coil in it. It could be a furnace, or which is the same as a hydro coil, but hydronic coil with airflow going over it. Kick space heaters, in-floor radiant would be another one, where the warm piping is right up against beneath the floor that you're walking on, and we use that radiant, that heat rising to heat the floors and eventually heat the room. So a lot of different types.
And hydronic heating is probably some of the most comfortable heating out there. You don't wake up with that dry mouth and just the very dry home. It's uncomfortable, and it makes for a miserable being miserable in your home. Really.
Yeah. Well, again, especially for us in the Northeast, because a lot of our air source, a lot of our air style forced hot air systems, they blow a ton of hot air in a short period of time.
Yeah.
They bring that temperature up, and then they shut off. Right, you get the blower to run for another minute or two, but eventually that's it. That's all you get is that direct heat source, and then it's gone. Direct heat source, and then it's gone. Whereas the hydronic systems, it's flowing that water through. It's at a much more controlled temperature.
Right.
And when your thermostat calls for heat, for example, it doesn't always, depending on how you have the system configured, it doesn't always kick your boiler back on. It may just circulate the water until we get to a certain temperature where we can no longer throw heat off of that, heat source, that heat exchanger, and then kicks on the boiler. So it can be more efficient, and there's a lot more control over the temperature going through each heat exchanger.
Yeah, it makes a huge difference, definitely.
Yeah. So the other thing we want to talk about is some components that we will see in a typical heating system. Now, this is a picture of a plate heat exchanger, which I didn't deal with a ton on the oil and gas-fired boilers.
Unless you were doing domestic hot water and it had a tankless,
Yes.
which is basically what this is.
Yeah.
Right?
Yep. So first one was, or the first specific to a plate heat exchanger like this was actually what I did my presentation on when I applied here, which was the System 2000.
I remember that.
By design, comes with a plate heat exchanger, and essentially they have just that. It's a indirect. It's a separate storage tank, but that storage tank is just fed off the plate heat exchanger. So the efficiency in that particular boiler comes from it being a low mass boiler. It only holds like 2.5 gallons of water.
Right.
So when there's a heating demand, it just runs this really tiny loop. Hot water demand, really tiny loop through that plate heat exchanger, so it can heat up really fast. It's only heating up 2.5 gallons of water and just running it through that plate heat exchanger. On the other side is actually potable, going to and from that storage tank, pulling it from the bottom and pushing it to the top over and over again to reheat that water. So that was the first like exposure to a plate heat exchanger. But you're right, a tankless coil is the same exact thing.
Yeah, it was very simple. It was just a coil bundle stuck into a boiler.
Yep.
And that hot water, that 180-degree hot water from the boiler would heat that coil. And on the outside of that, you would have your cold water in and basically a mixing valve.
Yep.
And you're going to temper the water to whatever potable hot water should, whatever's comfortable for that home. And that was it. It was very simple setup.
Yeah, yep. And with those, the only downside to them was you had to maintain a temperature on the boiler regardless of the time of year. So because the source or the heat exchange itself sits inside that boiler, we had to maintain, typically what we would do is we'd maintain 160 degrees on that boiler at all times. And that way, if there was a heat call or a hot water call, all right, we're feeding cold water into that coil, it's eventually going to start to drop the temperature of that boiler. It'll kick back on to, get that temperature back up. But you put a mixing valve on there, so you make sure 160 degrees isn't going out to your faucets. And the nice thing about that, too, is surprisingly, and I don't know if this was your experience, but there would be times where if it was sized properly, a tankless coil would be like almost infinity hot water. It would last a long time, especially with a mixing valve, the proper mixing valve on there. Like you'd be fine.
It's a customer loved it, and it never had to do anything. And it just, definitely.
The worst thing was when they'd be so rotted out and you'd be trying to tell the customer, like, you might want to just seal this off and we'll just add a zone as an indirect water heater. Right. And they're like, absolutely not. Find this tankless coil. Like, oh, no.
Absolutely. Yeah.
So that's a plate heat exchanger. It's basically taking fluid, usually in this case it's going to be water, into one side, and that's going to be our hot water, and then passing through the other side of that plate heat exchanger is just the secondary loop. Right, and that's going to go towards either a hot water heater or up to load.
We've been talking about fuel-fired systems, but our heat pump systems are going to utilize a heat exchanger in one way, shape, or form. Right, and with our EcoDan on one of our past episodes, we talked about the release of the new EcoDan. That has a built-in heat exchanger. Why? Because we're taking that hot refrigerant, so that refrigerant, we're splitting that right across the heat exchanger to heat that water. Yeah. So there has to be a separation in there. And the same thing with if you have a low temperature system, low pressure system and a high pressure system, it has to be split with that heat exchanger. Yeah. So
yeah. I mean, and it's the same rule applies for something like a monoblock or even our water source. I mean, it is a big heat exchanger. There. We're taking refrigerant on one side. That's our heat source or our chill source in some cases. And then the other side is the water, which is actually going to be carried out to your load. Right. So same basic idea. All right. Next one we'll talk about is this guy, which is a water feeder. So obviously we need to have water in the system in order for it to work properly. Now, if you have zero familiarity with hydronics, you have to have only water or some sort of glycol in the system. Any air will actually prevent flow of that water. It'll cavitate. It'll basically make an air pocket where no pump can push through that air gap. So these have to be watertight systems, no air in them at all.
And you mentioned it earlier, having enough valves. And over the years, I learned that, you can never have enough ball valves, enough purge valves and draw-offs, because when it comes time to purge all the air out of that system and you have a good setup, you can just push everything right out in one shot and not have to sit there and wait for a small air bleeder to do all the work. You can just push it all out. And this is a really important component of all that.
So the basic premise behind this is, an automatic water feeder. Some people call it a pressure reducing valve. But essentially what this does is it takes on the left-hand side would be our street pressure. So typically it's just city water, typically around 40, 45 PSI where I was from. And what it's doing is knocking it down to 12 PSI, but it's also maintaining that 12 PSI. Right. So if we start to see a drop on the boiler side or the system side of pressure, this automatic water feeder will open up that valve slightly to maintain a constant 12 pounds. And with this particular water valve, 12 pounds of pressure on the boiler side.
Right.
Now attached to it is a backflow preventer. And I think we have talked about this before, but the backflow preventer is essentially to prevent boiler water from escaping the system and going back out to the city.
Into the potable water.
Yep.
Yes.
Yep.
Yeah, really important.
Yeah. And the biggest causes for that, I think Paul brings it up almost every time we talk about a backflow preventer, is when they use the fire hydrants for fires. It can actually, because of how much pressure is being pulled through that fire hydrant, if you don't have a backflow preventer, it will actually drain your boiler out.
Yeah.
No.
Yeah, pretty impressive.
Yeah.
So that backflow preventer also has a connection on the bottom where you can pipe that down low. So in case it does start to leak, it can relieve that water somewhere.
Yeah, believe it or not, a lot of the valves or relief valves that we have, whether it's the backflow preventer or even the pressure relief valve, it's just an open port that you can do whatever you want with. We don't have anything electronic yet. This is, hey, our pressure is setting it off. On a typical boiler system, you find out that your pressure relief is going off because there's water on the ground. That's how you know. So
So our new EcoDan running pressure is going to be about 14.5 psi, which is very close. We're looking anywhere from 12 to 14 psi for a typical boiler setup.
Yeah, yep. And the nice thing about the EcoDan is it has the manometer on it. So, let's say you decide I'm going to put this Watts 911S on. They are adjustable. You can change the delivery pressure of these things. They come default at 12. But let's say you fill the system, you have the manometer on there that says, it's only at 12 PSI. Well, you know how to adjust this based on the system's manometer. So that's actually kind of nice to have. Having a pressure gauge right on the boiler like that. So speaking of pressure, let's go to expansion tanks. So again, another thing we've probably covered in past podcasts. The way that I like to describe an expansion tank is you see this metal barrel, and the bottom half of it, inside of it, is this rubber bladder. And I think of it like the inside of a basketball, right? And you inflate that basketball, the rubber bladder pushes up against the leather. Same thing is happening in here. You have this rubber bladder that's on the bottom half of that expansion tank. It's set to a certain pressure, and it fills up. Usually it's about half of that expansion tank. Now, the purpose for it is that when you heat up water, you will always expand.
Yeah.
Warmer water is going to expand. So what this does is allows for that thermal expansion without building system pressure, right? Because without an expansion tank, when the water expands when it's heated, it will build pressure in the system. The actual system pressure will increase. This will prevent that. It'll keep that pressure the same, because really what it's doing is just compressing down on that bladder.
Yeah, and it can, the system can, number one, be dangerous without an expansion tank.
Very dangerous.
Right? It's a pressure vessel, so it's essentially a bomb at that point. So having a functioning, when I say functioning expansion tank, make sure that it has the rubber bladder hasn't blown through.
Yeah.
Due to age and cracking over time, the bladder will bust through, and you can tell. We've all done this a million times. Take a screwdriver and you kind of tap the top of the tank. Should be a dull sound, like the tank is full of water, and on the bottom half should be a hollow sound.
Yeah.
Now, when you hear the same thing all the way through that tank,
Yep. She's slugged.
You got a tank that's full of water, and that bladder has blown through. But on the other hand, if we didn't have an expansion tank, our relief valves would make quite a mess.
Yeah.
So
yeah,
relief valves, that's what they're there for. they're there to relieve pressure, and relief valves can only open up so many times, and they're going to end up leaking.
Yes.
So we don't want that. So again, the expansion tank is really important.
Yeah. Yeah. Absolutely. They got to account for that thermal expansion. They're a big failure point. They're something that fails pretty frequently compared to other components in the system. So it's a good idea to keep an eye on it, and just make sure that it's something I used to do in preventative maintenance. When I would do hydronic systems and I would do preventative maintenance, one of the things I would do is give it a tap on the top and the bottom, make sure it was hollow on the bottom. Just because it's just one of those things that it's known to fail, and you may not notice it, especially in the summertime when there's not as long of run cycles. The water's probably not being stored as quite as high of a temperature, but in the wintertime you need that expansion tank fully functional.
Something that would drive me nuts is watching somebody take the cap off the bottom of the expansion tank and stick their fingernail in it just to see if this pressure Like you just let pressure out of the tank.
Yeah.
Now you're gonna have to recheck it.
Yep.
Right.
Yeah, that's a good point because I don't think we mentioned it yet, but with the expansion tanks, the intention for them is that they are set to the feed pressure, and you set that pressure on the expansion tank. You can do it just like you would pumping up a basketball. It's got a little Schrader valve or like a bike tire on the bottom, and you can actually pump it up. But you want it to be the exact same pressure as your intended feed pressure, and you want to do that when there is no water in the system. So you don't want to do it while the system's already full. You want the expansion tank not attached or attached with no water in it. Bump it up to that feed pressure setting, and then you should be good to go. If you have dissimilar pressures, you might have some issues.
Yeah.
So, in addition to expansion tanks, we've got our basics as far as feeding the system, make sure that we maintain proper pressure. But how do we actually control the water as it flows through the system? So there's different valves, control valves. And the basics are just a three-way diverting valve where you would have a single inlet, and then depending on the position of that valve, give you two separate outlets. So this would be, let's say you have a system where you want it to, when it is not energized, you want it to flow to, say, the direction of a water heater. But then when it does become energized, you want it to flow in the direction of a heat source.
Right.
So that two position is not so much open close, it's more open to one route, open to another route.
Right.
So that would be like a diverting valve. There's three-way mixing valves where we're actually taking in two inlets to give a single outlet. Now, this is really common, like you were talking about, on a tankless coil or most water heaters, where you may store your water heater at 140 degrees just to prevent Legionella, which is a bacteria that grows in low temperature or medium temperature water. But you may want to store it at 140 to make sure you kill it. The problem is you don't want 140 degrees going to your faucets.
Right.
So coming out of your water heater, you'll put in this mixing valve. One of the inlets is that 140 degree water. The other inlet is just cold water coming right from the city, right? City water coming in the other side. And then the outlet is what actually goes up to your faucets. And you have a dial that you can set your actual outlet temperature. And all it's really doing is changing the ratio of that 140 degree water and city water to make sure that we get that, say, 120 degrees going out to the faucets.
Yeah.
And then finally, which is the most common, at least in my experience, was the two-way, where it's either open or closed, and that's typically tied to a thermostat.
Yeah. So zone, and I have 5 of those in my house.
Yeah.
So basically, thermostat to each one. I'm very simple.
Yeah.
Everybody makes fun of me because of this, but I got 5 T80s. Well, I just upgraded to a Nest in my master bedroom.
Yeah.
Which is pretty cool, but everything else in the house is just T87s.
Really?
Old Mercury thermostats, 5 Taco zone valves, and a circulator.
Yeah.
And an old peerless boiler. And I say old, it was installed in 1988, which is pretty old.
That is old.
It's crazy to think that.
It's only 6 years younger than me. Yeah, so those are pretty common. You probably have the old school honeycomb styles, we used to call them, Taco zone valves, manual lever that you got to really crank down to get the thing to open up. But those are nice because they have 3 terminals, and so they can act as your end switch. So the nice thing about it is you don't need a zone controller for those. You just need a transformer, right? And that's going to help power your end switch. So if any one of them were to call or to open, it's just going to send that end switch down to the boiler to say, hey, come on, I have a zone calling. Whereas newer zone valves, some of them are set up that way, but some of them are just 2-wire, and they only get an on-off signal, and typically you're going to use those with something like a zone valve controller.
Right.
So just a quick peek at what some of those might look like. This is a zone valve. This would be your 2-way, where it's an inlet and an outlet right here.
Yep.
It's an inlet and an outlet. And essentially, this is a 2-wire lead. So when a thermostat calls, it may send a 24-volt signal out to open up this. And inside there is just a motor. And so there's a spring in there. It will spring close. There's always a spring fighting it to close. And then when it gets that 24-volt signal, the motor will override that spring and open up. It's a little like a flapper in there. It's like a hard plastic, flapper that will sit nice and tight against the body or the inside of that valve to prevent water flow. And the motor will swing it open when it gets energized.
This is probably one of your favorite valves. I mean,
Yes.
you expressed how
I love these
how much you
things.
like these valves because they're
Yep.
easy to service.
Yeah, so the valve is not tied to the head, the motor. So you can actually remove these pretty simply. You just pull on the manual valve and a little twist, and the whole thing just pops right off. So no screws have to come out. It's literally just held in with the manual valve and the manual lever, and it's kind of almost like clipped in. So to release it, you just kind of twist and pop. But what I like about these even more is that, let's say the mallet or the paddle that's in there that actually is doing the opening and closing, if that were to fail, you don't have to de-sweat this from the piping.
That's
you
huge.
can actually take the screws right off the front of that body, and the whole internal guts pop out. You can just put a new one in, and now everything still stays sweat into the piping. You don't have to worry about cutting it out and reconfiguring a new one. So I love these things. No. All right, next one is a three-way valve. So this is what we were talking about before, where you may want two different directions, where when it's not energized, it's flowing to a water heater. When it is energized, it's flowing to a heat source.
Right.
And so the output signal to actually turn this on, let's say it turns it on, when it's energized, it's giving you the feed to the heating system. So it defaults to be able to make your hot water. If it were to fail, you're still going to have your hot water, but you want it to energize for heating so that it can flow to the heating side.
Right.
Yep. So 2 outlets, single inlet.
Yeah, with all of these valves, multitude of voltages, 24 volt being
Yep.
the most common. Then you have 110 volt valves and also 230 valves.
Yeah. It's something I learned recently. It's just some 230 valves out there. You may need them.
We'll be seeing them with our heat pumps.
Yeah.
That's for sure.
Yep. So now we just need something to move the water. So we have something to control the flow of the water. Now we need something to move it. And this is a typical residential circulator. So these are the ones that we put in a lot, the Grundfos circulators. We did put in a lot of Taco 007s and then the Taco 007Es. This is pictured a Grundfos. What I like about this is their speed control. So there's a speed selector, low, medium, and high, which allows you to dial in your flow, which really dials in your capacity.
Something that was scarce in my time installing it. They were just basically on and off, and that was it. What
Yeah.
you get, you know.
Yep. Which, I mean, yeah, even when I was, and this was, one of the newer types of circulators, you'd see them in like on-demand boilers when those came out, or the combi boilers. But basically all these circulators are differential pressure machines. That's all they do. They create differential pressure. So what they're trying to do is build pressure on the head side, and then it creates a suction pressure, and that's what allows that water to flow. And so a lot of people think that these are really pushing or pulling water. And so there's a lot of discrepancy on, where do I put this? Should I put it on the supply? Does it go on the return? In the grand scheme of things, there's some things to consider as far as where you put it. A lot of times would see them on the returns, but then you'd see systems that would have them on the supply. A lot of times I saw them on the return. But at the end of the day, it's only so important because it's really more important about where you actually feed water to the system, where your expansion tank is located. These are there to create a differential pressure. And so when it comes to the expansion tank, you want that at the point of no pressure change, which is going to be typically right before this pump, right? So if you put it after the pump, that's when you could run into some potential issues because it's trying to create a differential pressure, but you just put an expansion tank that maintains a pressure. So if you don't have enough, pressure on the inlet side of this pump, it can't actually give head pressure out, and so then you wouldn't have as good a flow through the system. These also come with internal flow checks, which are incredibly important. I've actually had service calls where there was not a flow check installed, or there was a faulty flow check, and it was middle of winter, but this certain loop that they did not have the thermostat calling for, the baseboards were hot. All right, and I'm like, why are these baseboards so hot? Well, I went downstairs and I felt the piping for that loop, and the return piping was like boiler hot. And it's all because there was no flow check or a faulty flow check in that loop. And what that flow check does is just like any other flow check, it's only allowing flow in one direction. And so typically they're facing the boiler. And the point of that is when the boiler shuts off, it's typically at the lowest point of the house. In our case, it's the basement. So with that boiler in the basement, the hot water is going to want to migrate up. And the flow check prevents that from happening. without the flow check, the water's going to migrate up, and that's what happened. And then the second floor baseboard, felt like boiler water. It was putting off heat, and it's simply because it was reverse flowing through the system because of that hot water and the difference between that and the water at the second floor. So these come with flow checks. If they don't, you got to put one in. All right. Next, we've got air eliminators. So 2 different types. The one that I got really used to working on, which is the air scoops that Amtrol makes. It's got the little 1/4-inch port on the top, and then it's got the 3/4 off the bottom, or sometimes half off the bottom. And that was for typically where you'd put your expansion tank.
Yep.
And maybe even feed the system with it. But at the end of the day, these are just there to remove small amounts of air from the system. Yep. The other side would be the spire vent. So that's what we see on the right-hand side there. The spire vent, same basic idea. They're hydroscopic is what they're called. But they serve the same purpose. They typically, I'd see them right off the top of the boiler. The air scoops used to come with the boiler trim kits we'd order. Right. So we'd get the trim kit, and it would come with the air eliminator. And it was basically a couple pieces of black iron and then your air eliminator, so that right off the top of your boiler, you're scooping any of that air out. That 1/4-inch port on the top is where you'd put something like a vent in order to push that air out.
Yeah. Things have changed quite a bit. When you had the cast iron air scoop, we would just screw the expansion tank into the bottom of that. But the expansion tank would fail. Now you'd have to drain the whole boiler just to change. Now they put a ball valve in there. We've gotten a lot smarter with that stuff.
Yeah. So these are required. You're not going to be able to get away with piping a system without some sort of air elimination, because even if you purge a system perfectly and you have no air in the system based on your purging practice, when that water heats up, it will release microscopic, they call it like saturated oxygen that exists in the water.
Microbubbles.
Microbubbles, yeah. So when that water does heat up, it's going to release some small amount of oxygen. And if there's nowhere for it to go, it will cavitate your pump, and then you won't have any flow of water through your system. And so these are specifically designed to catch those microbubbles. They're not going to purge a whole system for you. They're specifically designed to catch those system microbubbles that occur during operation.
Much more efficient than a small automatic air vent that would go on a T or something, and a lot of air would bypass and not be able to be released, where this grabs all of that air, or most of it, and vents it right out. So really efficient air vent.
Yep. Yeah, they're definitely something you need to have on a hydronic system. So those are just kind of the major components. Obviously, you need thermostats, right? You need things to actually call things on. People know what thermostats are. But I want to talk about some of the actual heat exchangers or heat choices, right? So what are we actually sending this water through? So first is just baseboard. So this looks like little trim board on the bottom of your wall, and typically it's metal, and if you ever knock it down, it's a pain in the butt to get back on there, especially those end caps, making sure they line up perfectly. But it's just fin tube, right? It's one tube and then a bunch of aluminum fins that help move that heat off of the pipe, and then typically there's a little metal decorative cover over it. And the reason we put them close to the floor is, again, we're using the rules of thermodynamics. That coldest air is going to drop. It's going to have that warm heat source near the ground, so it's going to want to pass through that. And once it passes through, we start pushing that warmer air up through the top. So using basic convection there. Next are these kick space heaters. So we used to have these underneath like kitchen sinks. So it's just hydronic piping goes into this coil. Bathroom sinks, kitchen sinks. I had one on a set of stairs once. So they had built this little, like it was 3 steps to go from a lower part of the house to like the living room area. And they basically had built removable stairs. You could just lift the whole thing up. And underneath it was a kick space heater that would blow heat into that in the lower space. And basically the way these work is it's hydronic coil in there, and there's a blower. But that blower doesn't kick on right away. There's actually a temperature clamp that's on the piping, and when it reaches a certain temperature, which you can usually set yourself, we always used to do like 140-ish degrees. Once the pipe was about 140, then our fan would kick on and start delivering the air over that hydronic coil and then out into the space. So another option. Next one would be the garage heaters. We used to call them hot dogs. You might have seen these as a gas, where it's actually just a
Modine.
gas. Yeah, Modine makes them. But they do also have hydronic ones, and it's the same premise as a kick space heater. Hydronic coil, air blows over it at a certain temperature. Next, I wanted to show was this radiant, and I particularly chose this photo because it drives me nuts. I'm assuming this is not a finished radiant loop because there is no insulation, there's no air gap. So I'm hoping, and there's also no radiant fins. So I'm hoping this isn't a finished project, but essentially the way the radiant works is exactly what it looks like. It's tubing, hydronic tubing that goes in between floor joists. And the intention is that heat is going to rise up through the floor joists and into the floor of the living space. But typically what you'll see on a finished project is there will be some insulation in each of those bays
Right.
to make sure that the heat doesn't start to migrate downwards. It forces it all upwards. Depending on the type of radiant, you may have radiant fins that actually clip on, and you're supposed to put them on every 12 to 13 inches. And then typically you want some sort of an air gap. So these are stapled right up to it. So usually you'll see a little bit of an air gap between them.
Right.
And these are things you have to be careful of with these are temperatures. So if you have a boiler that runs up to 180 degrees, you wouldn't really want to send 180 degree water through these loops because they're in contact with the floor above it. I've seen tile floors that have either buckled or actually cracked because the floor gets so warm.
Right.
So you got to temper this, and this is where those mixing valves come
Mixing
back in.
valves and the three-way valves you talked about, and different ways of getting those different temperatures. You know, the hotter water to your baseboard heat, and like you said, the cooler water.
Yeah, to temper this stuff.
Yeah, 140 usually typical. I've seen this in specialized concrete as well on the floor, where they lay a special type of concrete where it will transmit that heat, and it's very comfortable.
Oh yeah.
It's nice to walk around your house, have some heat under your feet like that, especially in the bathroom.
Yeah. The people in my area, if they had money, you knew, because they would have driveway melt.
Yeah.
And they would do this under the driveway. And
I've
when
seen
it would snow.
I've seen electric driveway melt, yeah.
Yeah, but it's awesome because, you think about it, it's like they never have to shovel their driveway.
No.
They just put that on there. If it's just snow, it'll melt it right away.
When going back to the wood-fired boilers,
Yeah.
that's where you really get the money's worth. If your house is piped that way and you have a driveway that has that radiant heat in it.
Yep. It'll save you
fantastic.
back. Yep. And then the last thing I wanted to show is the zone controller. So this kind of puts everything together. This brings everything together. You take your thermostats, you've got your zone valves. You need something to tell your hydronic system to come on, whether it's a boiler or like a pellet boiler, gas, oil, could be the EcoDan, could be heat pump boilers, but you need something to tell it to come on. And so what this zone controller does is it will account for however many zones you have. It could be, you could have 2 zones, upstairs and downstairs. You said you have 5 zones, so you could get a zone controller that will take care of 5 zones and 5 zone valves. And the way it works is when that thermostat makes a call onto that zone valve controller, it says, okay, I received the call. I'm going to output 24 volts to the corresponding zone valve. Now we've opened up flow to that zone. At the same time, it also sends 24 volts or a closed contact on the end switch XX to whatever our heat source is and says, hey, I got a call over here. You need to kick on. The other thing we can do with it is energize pumps. So we can actually run circulators through this one zone valve controller. So this is like an all-in-one. The only thing it doesn't do is make the heat.
Right.
It just tells the heat to come on.
Yep.
So these are great. They're very similar to a zoning board if you're more accustomed to air, right? With the EWCs or Honeywell True Zones, right? Those are just zone controls, same basic idea. Same thing applies with these zone controllers and Hydronic. They're just controlling zone valves, or in some cases circulators. You might have a bank of circulators instead of using zone valves, and every individual zone has its own circulator. You can do that too.
It's a great way to manage
different type.
all of your components, all your transformers, everything is built in. The transformers are built into this, so
Yeah.
there's no external wiring, additional components, relays, and things like that. Because I've been there,
Yeah.
And so this was a huge improvement to the industry.
Yeah, you just got to give it 120.
Yeah.
It'll take care of the rest. Now they do have a transformer in there, and I have in a pinch replaced it with just a typical HVAC one because I didn't have a replacement board, so it worked out. I got lucky, but you know, it's an all-in-one, which is nice, and it's got LED lights for the homeowner, so they know which zones are what, and you can label them if you really want to, you know, get specific and do it the right way. But
I'm going to tell you something. I've been with Mitsubishi 8 years, and I'm going back 8 years ago. If you would have told me I was be talking about hydronics at Mitsubishi, I would have told you you're crazy.
I know.
8 years ago, we had our residential and commercial line, and it was all VRF. It was just mini splits and commercial VRF. Now things are changing.
Yeah.
So,
Which is a good thing.
yeah.
You know, it is also nice because, like you were saying before, was some of the most fun I had when I was in a van, was working on hydronic systems.
Yeah.
And so it's scratching that itch for me a little bit to exercise all those hydronic muscles that I used to use more often.
All right.
That it?
That's it.
I think that's it.
Yeah. So what's
You didn't eat lunch today, did you?
No.
No, too busy.
Doing like a fasting thing.
Oh, okay.
A sunflower seed diet.
I've got about 8 ounces of chicken sitting in the hallway right now that I couldn't get into.
Oh, I saw that. Yeah.
I heated it up. I was doing the meal prep thing, and I heated it up, and then I took a couple bites. I'm like, I'm not hungry enough to eat this right now.
Yeah. I don't know. I'm doing this weird thing where I'm like fasting and doing the carnivore
Yeah,
diet.
it's extreme.
I just noticed that when I just don't eat anything I had a weird routine. It was bad habits. It's Dunkin' Donuts in the morning, medium hot regular, which is like filled with sugar. And then bacon, egg, and cheese croissant sandwich. And then, do you want hash browns? Sure. Throw those in. So it was just like every morning, bang, bang, bang.
Yeah.
Stopped it. I actually have gone to black coffee.
Okay.
Which is very hard for me to do. Like, Paul gets on my case all the time. Well, you're going to put all that foo-foo crap in there.
Yeah.
No, I like my cream and sugar or sweetener in the coffee. But I've been going to black coffee, and now I'm kind of getting used to it. So
Okay, that's good.
every little bit helps, but I'm trying to trim down, and hopefully, this does it.
I'm excited to see it.
So-
When you told me you went to the gym,
I did.
been going to the
and,
gym, I was like, oh, this is awesome.
yeah.
Love it.
Yeah.
Just get
So I just got to
jacked.
keep it up. I just got to keep going. But yeah, I'm excited for the DSG conference next week. We got 450 DSGs that are planning on being there, and bunch of breakout classes. What are your breakout classes?
I'm going to do an update on some of the A2L. So it's actually some of the stuff we covered in the podcast a couple weeks ago, but just hammering some of that stuff home, and then a little introduction to the EcoDan, and then a little bit of discussion about the updates to the IntelliHeat with the A2L launch coming soon. So.
Yeah, so our DSGs, that's our Diamond Service Group members, and they're really important to us. They are the first line of defense for our contractors. They're the first ones that go out and take a look at any issues you're having, try and help you out. So we like to keep them trained, and we like to spend time with them.
Well,
that's important.
that's
spend time with them, and there's going to be a cigar rolling
I heard about that.
booth.
Yeah.
So that's going to be pretty busy.
Yeah.
Some live music at this event.
A poker night, I think they said.
A poker night. Yeah, we got like a casino night, poker night type thing.
Yeah.
And we spend time with all these great bunch of people.
Yeah.
From all over the country and some international.
Yep.
Right. So looking forward to it.
Yeah.
And that's all I got.
Yeah. So I would expect the next podcast to be on site at the DSG
Oh yeah,
conference.
that's so the Metis Tech Show will be on site. Paul and I we got our work cut out for us.
Yeah, you do, because I won't even be able to help you out.
Yeah. So we'll
You'll
have
be
to
operating that.
get you on there a few times during the week, whenever chance we get.
Yeah.
But
You'll have to be doing the producing.
so you'll be hearing a lot of live shows from the DSG conference.
Yeah.
A lot of people chattering in the background.
Mm-hmm.
So.
Well, it won't be Palermo's audio, though. Or Bryn.
No.
It'll be a little better than that.
Better audio. We got the podcast kit, the legit kit we just sent to Austin, Texas. It's on its way there.
Yeah.
So,
Exciting stuff. All right, everybody. We'll see you on the next one.
yep. See ya.